Hi, this is Miss Eric, and we're going to go over the question relating to F-L-E-B. F-L-E-B, and that is interpret expressions for functions in terms of the situation they model. So this is taken from the June 2014 test, question number 26. The breakdown of a sample of a chemical compound. So breakdown. Now as soon as I hear the word breakdown, I'm going to think of exponential decay. Okay? Exponential decay. Now, anytime I hear things with money or interest or compounded, which is not in this problem, but if I hear it, I'm going to think of exponential growth. Now, the equations that match up for this, and 1 second, gotta turn my light back on. The equations that match up for here are going to be A equals P parenthesis 1 space R T, where A is the total, P is the initial amount, 1 plus R, that is either if it's positive or if it's greater than 1, that's going to be our rate of growth. If it's negative, or if the number is less than 1, that is going to be our rate of decay. So now that we have that information back in our minds, let's look at the problem. The breakdown of a sample of a chemical compound is represented by the function P of t equals 300, 0.5 t, where P of t represents the number of milligrams of the substance, and t represents the time in years. In the function P of t, explain what 0.5 and 300 represent. So let's write the equation down. We have P of t equals 300, 0.5 t. It already told us that the P of t is the total, or the number of milligrams, and it told us that the t is years. Well, if we look at our formula over here, we know that this 300 stands for the initial amount, and we know that this 0.5 stands for the rate. But we have to determine if it's the rate of growth or decay. Because 0.5 is less than 1, we know it's going to be the rate of decay. So to make it look pretty, we can say 0.5 represents the rate of decay. .300 represents the initial amount. Okay, that concludes this question. Great job.